Hey everybody, welcome to another tutorial on sequencing with signals in Max. So this video is part 3 of a 3-part series where we started by building a simple Euclidean sequencer, single track. And in video 2, we converted that into a multitrack sequencer using MC. And now in this third video, we're going to extend the usability of this by adding more of a user-friendly UI that gives you control over each of the individual tracks pretty simply, and also supports presets that you can, so that you can recall the entire state of the sequencer very quickly and easily. If you want to understand more about how this is working, I definitely recommend watching the last video, but I'll quickly recap it right here. So first off, we have a phasor object, which is outputting a sawtooth signal. And then following that, we have a subdiv object, which is outputting also phasors, but just 8 of them for every one of the input. So every time this ramp goes from 0 to 1, we get 8 over here. And right now we're just working in the default state, so that's all it's doing. But we actually have control over which of these subdivided phasors actually appear. So if I say I want to control the first track here, which is the one we're currently viewing, and I want to have a let's say 7-step sequence with 3 events, now I get a 3-event Euclidean pattern, where you can see we only actually are seeing some of these ramps because some of them are being omitted. And the pattern looks like this, is sort of a representation of 0s and 1s. And when we actually send that information, let's try for the second one. So we'll make a 9-step pattern with, say, 4 events. What we're doing is we're telling, using MC target, we're sending this message prob followed by this string of 1s and 0s for a given channel. And the way that we're specifying that channel is using this number over here. Those subdivisions are triggering MC.MIDI player, which is working in conjunction with a multi-slider and MC.stash in order to send note values onto MC.MIDI player, which is creating a MIDI event for us, which we're then sending out to whatever MIDI gear you might be using. And in this particular video, we're not going to mess really with anything below here. And in fact, we're not even going to make any sounds, because all we really care about doing in this particular case is looking at this scope here and seeing how we can modify each sequence in different ways. So let's get into that. So what we want to get to, basically, I think, is something that looks a little bit like this. So we have this grid of numbers, and the first column is for steps, the second column is for events, the third column is for rotation, and the first row is for the first sequencer, second row for the second, and so on and so forth. We also want to be able to have any state of this, as well as the state of things like our notes configuration, as well as our subdivisions, as well as our poly mode, be able to be saved as presets. And I didn't mention those a moment ago, but these subdivision and the poly mode, these are global parameters that basically control whether the sequencer is operating polyrhythmically or polymetrically. And if it's operating polymetrically, what should the subdivision be? And again, if you want to understand that more, go watch that other video. All we're going to do now is just hook these things up so that they can be controlled by by presets. So the way that we're going to do this is using pattr system. So I'm going to create a pattr storage object, and I'm going to give it a name. And I'm going to set its greedy attribute to 1, and I'll show you why that's the case in a second. And if I double click this, it can tell us what client objects, or in other words, what preset enabled parameters exist in this patch, and there aren't any. So the first thing that I'm going to do is just create pattr objects for some of these global parameters. In fact, for all of them. And this isn't the only way to do this, but it's one way. And if I double click this again, you can see that we now have those saved. And now we need to have one of these rows for each of these Euclidean parameters for each of the 8 sequences. So we're going to need 8 times 3, 24 different rows in here for track 1's steps, track 1's events, track 1's rotate, and then the same for track 2, track 3, etc. There's a bunch of ways you could do this, but one that I really like is to use a poly tilde and actually host our Euclidean generator inside the poly tilde, which allows us to create 8 instantiations of that generator and then remotely control the parameters inside of it. So that's probably a little confusing. Let's actually build it and you'll see what I mean. So the first thing I'm going to do is copy this. And I'm going to open it. And I'm going to add pattr objects that live inside of it and actually replace the inlets. So I'm going to create one for steps. I'm going to create one for events. And one for rotation. And I'm going to delete that. Great. And then I'm going to create an outlet that is these inlets and outlets that are, rather than outlet, it's out plus the number, which are the way that we create inlets and outlets for poly. And so now that I've done all this, I'm going to save this. And we're going to call it Euclidean gen.maxpat. And so now if I say poly Euclidean gen, and then I say 8 because I want there to be 8 of those, and I open this, you can see we can see our same patch. And if I double click our pattr storage, you can see we now have 8 instantiations of that Euclidean gen pattr are visible, and they have this syntax, there's this naming syntax that's poly tilde dot to with our 3 parameters. And the reason it's poly tilde is because that's the scripting name of this object. So I'm going to change it to generator. And if we double click that again, we can now see we have generator 1, generator 2, generator 3 with the parameters inside. Now, to actually control those, what I can do is copy our UI elements and create a pattr object and say bind to generator 1 steps and also invisible 1, so that this particular pattr object does not appear in our list inside the pattr storage. So you can see I've created that, but I actually don't see it in here. It's not. It has its own weird scripting name, which is U339011, etc. But it actually doesn't show up in here. And the reason is because I'm basically just using this as a sort of like a send and receive to remotely control the pattr object that is inside of this poly object. So now, if I connect some message boxes to this poly, and I manipulate this message box, or number box rather, you could see that I'm actually controlling that first the steps parameter of that first instance of that Euclidean gen patch. So now if I do the same thing for the events and for the rotation, I can remotely control that first sequence. So basically what we're going to do now is just create 8 more versions of this that have different numbers here. So rather than 1, 2, 3, 4, 5, 6, 7, 8. But first, I think just to clean things up a little bit, I would love to encapsulate this and just have it be a bpatcher in presentation mode where all we can see are these 3 number boxes. So I'm going to go ahead and do that. So I'm going to say Command-Shift-E. I'm going to click into that. I'm going to highlight these and press Command-Shift-P to add them to presentation mode. And then I'm just going to move them into the upper left-hand corner here. I'm going to go to the inspector, the patch inspector, and say open a presentation. And then close that. And then transform pattr to bpatcher. And now it should be that if I control this, we get something here, but we don't. And the reason that is because this bind to feature in pattr, it works based on the relative location of these pattr objects within the pattr hierarchy. So when I say in this particular case, bind to generator.1 steps, it's actually looking for a subpatcher whose name is generator.1, which doesn't exist. So what we need to do is basically tell it to look 1 level up within its parent patcher and then go looking for generator.1. So the way that we can do that is to add to the beginning of this path parent : : I really wish that I think it'd be a really awesome enhancement to the pattr system in general for anybody from Cycling 74 who may be listening to find a way to not require this, to like have globally, basically absolute paths. I understand that might be kind of difficult. There's probably problems, but it would be super nice. But anyway, now that I've fixed that, if I mess around with the numbers, you can see that it's actually now controlling our poly object. So now what we have is 8 versions of this same thing, and we can use an abstraction that looks just like this one to control all 8 of those instantiations. And you can see that it outputs 3 things. The first is the pattern itself, just like our original subpatcher does. The second is the settings of the sequence. And then the third is the voice number, which basically replaces this number box that we're using here to tell mc.target which of the 8 channels of mc.subdiv to control. So if I just put a root object here, just to get rid of that word voice, I can now replace a bunch of these connections in our existing patch with this new poly object. So I'm going to delete all this, and I'm going to move this into place. Cool. So now, again, this is channel 1. Steps, events, rotation. I can now control that. So I could say, let's go up to 9. And if I come over here, you can see that that should be reflected. If I turn our poly mode off, you can see it immediately change the subdivision, the sort of granularity of the subdivision, from the 8 that it was because actually we never sent anything here. So if I send 16 and turn this off, it's now 16. If I go to 8, it should be 8, although is it working? There we go. But now if I turn the poly mode on, now it's 14. Okay. And if I simply copy this and open it and edit it and change these 1s to 2s, I can now control the second channel. Now, there are cleverer ways to do this if you want to, where you can, because you can send a message that says bind to, parent generator.3 steps if you want to, and change what pattr object or sort of what parameter within our poly object this pattr is referencing. And you can use that technique basically to create an abstraction where you maybe set an argument and it just automatically updates the bindings for all of these, which is cool, and I've done. But in this particular case, I think we can be happy with just going in here and manually editing things. And let's just do, the first 2 for now, but you get the picture on how you could create the rest of them. And we can now set, let's say, that second one. So if I go in here and I open the client window again, I can see I have my subdivisions value is saved, my poly mode, the notes that I have selected, which let's change those so that they're not all the same. Cool. So we could see those reflected here. And then the settings for the first and second pattern generators, and the settings for the other ones too, but right now there are no patterns for those. So let's talk about how to do presets now. In pattr storage, there's a thing called storage slots, and I can view those by setting the message storage window. And right now there are none. Let's create one. So there's a lot of ways to create them, but an easy way is to create a preset object and then use the pattr storage attribute and give it the name of the pattr storage object that you want this preset object to control, which is going to be, I believe, MC_Eucl. Yes, cool. And now if I hold shift and click this first cell, I now have a saved preset. And if I open the storage window, you can see that that's now saved. I can change some settings. I can turn poly mode, change the poly mode. I can change subdivision and save the second one. And now if I open the storage slots, you can see that those are saved. Okay. And you'll notice now I can recall those. So now we're on the second one. But if I want to reload the first one, you can see that our subdivision and our poly mode both changed because between the two of them, the values aren't the same. But actually, our sequencer parameters didn't. And the reason is because we have to make one additional modification to those controls. And it's to add this. So each time the new preset is recalled, the pattr object is going to update the new value. And so what we'll do is just add a set, or basically take that value, prepend it with set, and send it back into our number box. We're just going to update the value of the number box without outputting the value. So now I have this added for the first row here, but not for the second. So if I change the preset, you could see that the first one changes, but the second one, even though actually the the sequence is the same, or the settings are the same, but if let's say I change them, I go to 40, and then I save this for resave preset 1. So now preset 1, sequence 2 has 40 steps. And I switch between them. The first one is changing, but the second one doesn't, even though it should, because we have 40 and 9. So I'm going to delete that one, come back here. By default, it's looking at 1 because I just copied 1, but I'll change it manually. Oops. Oops, 2 again. There we go. And so now if I change it, you could see it's actually updating. So this is a pretty powerful way to do things, I think, because it puts the parameters inside of the sort of engine of the patch, like where these things are actually happening, right? Where these values are actually being used by the patch is where the pattr objects live and where the parameters are being defined. Then we have a user interface that is just responsible for sending values and displaying them. And we make the use of these pattr objects with the invisible attribute set to actually send those values and also receive new values anytime we load a preset. This also has an additional nice sort of function of allowing you to have multiple UIs that actually control the same underlying model. So if I wanted to have, a really detailed UI that allows me to control everything, but then maybe have a different one that's a little bit more simple, and I can do that because anytime I use this setup where I have the parameter defined using a pattr object inside the model and a pattr which is bound to that one and invisible with the set message, then my UI objects will always stay in sync with whatever the state of the linked pattr object is. So if we go back and look at the storage window, we can see now we have these different presets stored. And now the only thing that we really need to do to make this a really nice UI is create a presentation mode. So I'm going to add all of the objects that we want in presentation mode that we want in presentation mode. I'm going to enable that. The MIDI channel could be one too, if we wanted to add a pattr MIDI channel, but I won't do that for this moment. And we're going to also want to put these labels in. Let me put this down here. We actually don't want this in there, so we can remove from presentation. But we could add a label if we want. Oops. And we could create, obviously, 8 more rows all the way down and just go in and modify those values in the pattr objects in order to be able to control our multi-channel sequencer. Cool. So that's that. This general sort of approach is the one that I really like to use. There's tons of other ways to handle kind of this question of control and presets within Max. And I know that other people use other approaches. One thing I've seen a lot is they'll have sort of a view patch similar to this one, and then they use send and receive to talk to the model. I really like this technique that uses pattr just because it gives you tons of flexibility to be able to use different UIs for things as well as use presets really well. On my laundry list of things that I would love to see from Cycling 74, in addition to the kind of idea of a global namespace for pattr, would also be like an object that might be called like pattr remote, which is by default invisible, basically an alias of pattr that is always invisible, and where the first the first argument is just the bind to. That would be super nice in my opinion, but this works super well as well. Oh, and also it would have an output that outputs a set message because we know that we're going to need that. The only other thing to talk about is once you've saved all these presets, how do you actually make sure that they're available to you the next time you open the Max patch? There's also a bunch of ways to do this, but one way that I really like to do it is the first time I create the pattr storage object and I'm saving my patch, I will send this message write XML or write JSON, whichever you prefer. XML and JSON are just 2 different file types that are similar but not the same. So whichever one you like more is fine. And I will also give the pattr storage object the attributes save mode 2, and auto restore 1 is already the default, but we can add it here just to be explicit. And you can see once I did that, it asked me to save a file, and I'll just save that as mcucl.json. And we can actually go look at that. So if I go back into my file system here, and I open this with, let's say, Sublime Text, you can see we have those presets. And I don't care about all that. And the reason we did save mode 2 is because save mode 2 makes it so that if I add more of these, anytime that I save the patch, so that if I just hit Command S or I go up here and hit save, it's also going to save that pattr storage file. So it'll save the current state of basically the storage window to the JSON file. I really like that. I think that that's the simplest way to work. If you want to work a different way, you can investigate in the reference documentation this save mode attribute of pattr storage, which includes a lot of different ways for you to control when exactly the JSON file gets saved. The auto restore, basically all this does is tell pattr storage to load the most recently saved file. So if I reopen this patch, it's going to know that last time I was here, I saved to mc-ucl.json, and it will just load that for me when the patch initializes. So now that we have that all done, we can also add our preset object to our UI and move it over here. Cool. So hopefully that gives you the building blocks of building really cool, really useful UIs that allow you to, once you're done patching, once you're done making your device, actually use it in a way that doesn't require you to sort of wade through your patching, but be intuitive and have fun making music. Let me know if you have any questions down below, and I'll see you next time. Thanks.